In this video, we're going to solve quadratic equations using square roots or radicals. So you may hear them referred to in both ways. Remember, the square root symbol is called a radical. Now, on this first screen, you'll notice that the first question we're actually given is to find all zeros of a function given the equations here. Now, you might remember that zeros of a function are the same thing as roots or x-intercepts on a graph, or the solutions when y equals 0. So the very first thing that we're going to want to do is go ahead and plug in 0 for y into each of our equations. Now you might notice there's a very big difference between the two equations here. The equation on the left, you have an x squared term. Same thing with the equation on the right. That's what makes these both quadratics. But on the left, we have an x term in the middle. We have an x to the first power, a linear term. On the right, we don't. We only have a single x squared as the only variable x in that whole equation. Now, previously, we learned that if you have both an x squared and an x, one of the great ways to solve this would be solving by factoring, because we need to split this up in order to get those x's separated. So we could call this x and x. We know that 6 and 8 multiply to 48, and their difference is 2. So my guess is we're going to be using a 6 and an 8, the 8 being negative, so when they add, it'll come out to a negative 2 in the middle. And now we can separate our two equations, either x plus 6 equals 0, or x minus 8 equals 0. So I can subtract my 6, add my 8, and get my two separate answers. The key being, in this step here, we could separate into an equation that only has a single x, and again, this equation only has a single x. One variable means I can solve and get it by itself. One term that has a variable in it. Well, notice over here we only have one term with a variable in it. So the first thing I would do is actually not worry about factoring. I'm going to go ahead and just add 108 to this side, as I essentially already have x close to by itself. There's no second term with an x in it that I have to worry about. Now I could just divide by 12, giving me 11. 108 divided by 12. Divide this side by 12. Actually giving me 9, sorry. Not 11, giving me 9. 12 over 12 leaves you with just x squared. And now we can use a square root. If you're trying to get rid of something squared, remember you can take the square root of both sides of your equation. And we can say that x on the right is equal to 3 on the left, because square root of 9 is 3. Now, one thing you also want to remember is, much like an absolute value, remember that what we're saying in this red equation was that some number squared gave you 9. And in the world of algebra, there's only two numbers out there that do that, but it's not just one number. Remember, yes, positive 3 squared is 9, but also negative 3 squared can also give you 9. So technically, there's where we get our two answers. Remember, with quadratic equations, we kind of expect to have two answers. The biggest key you want to remember is whenever you take the square root on both sides of an equation, you have to say plus or minus. Because remember that 9 could have come from negative 3 being squared. It also could have come from positive 3 being squared. So when we go backwards, we need to be able to split to solve. On this next screen, we've just got a couple of straight equations. Rather than having them be something where you're finding zeros or something like that, we're just finding the solutions to our equation. So let's go ahead and just solve away. Again, start with the easy steps first. Plus 7 is an easy thing to get rid of in this equation. I'm just going to subtract 7 on both sides of my equation. So this becomes 4x squared equals 16. Go ahead and divide by 4 on both sides. We get x squared equals 4. And again, take that square root on both sides of our equation. Again, don't forget to say plus or minus. So x will be equal to positive or negative 2. And you can just write it exactly like that, plus or minus 2, telling us there are two answers. Either x is positive 2 or negative 2. Now you might be tempted to FOIL out x minus 5 squared over here in this equation. What I would do is discourage you from that. You only have a single variable right now, and if we FOIL that, we'll have both an x squared term and an x term. So the better thing to do is let's start thinking about what we can get rid of easily. This 2 multiplied on the outside can easily be divided away. So let's just cancel those out, and x minus 5 quantity squared is really just equal to 25. Then the next thing to get rid of, the last thing happening on that left side, is actually our square. So let's square root. And don't forget to say again, plus or minus. So this becomes x minus 5. And on the right side, you have plus or minus 5. Now this is a great time to go ahead and split it into two equations, because x minus 5 could be equal to positive 5, or x minus 5 could equal negative 5. And when we add 5 to all sides here, adding 5 on this side means we get 10, but adding 5 in this equation actually means we get 0. And our two answers would be 10 and 0. Remember that you can always take those, plug them back into your original equation and make sure it works. 10 minus 5 squared times 2, so 10 minus 5 is 5, squared is 25, times 2 is 50. And 0 minus 5 is negative 5. Squared is 25, times 2 is 50. They both work. On the next page, I just have a couple more quick examples for you. Go ahead and solve these. I'm going to pause the video now to save a little bit of time, and I will fill in the work and show you the answers. All right, I've got all the work filled in here for you. Notice in this first equation, we just went ahead and added 2 to the other side. Since I'm dividing by 6, I just multiplied 6 over to the right side, and then I took the square root, which, remember to say plus or minus, will be the square root of 12. Now you have to make a decision between whether or not you're going to go with an approximate solution, which means just typing it straight into the calculator, rounding accurately to 3 decimal places or more, which is going to come out to a positive or negative, again plus or minus, 3.464. Or, depending on the directions, which note on these directions, they didn't say one way or the other, but if it said anything about finding an exact value, or you wanted to keep them more precise, you could also break down the 12. Remember, the 12 is 4 times 3, so we could have said square root of 4, square root of 3, and remember the square root of 4 just becomes 2. So you get plus or minus 2 root 3 over here in green. On the right side, first thing I did again, I didn't FOIL, I went ahead and just got rid of the half by multiplying each side by 2. Then I took a square root in blue there on both sides, canceling off the square, leaving you with plus or minus the square root of 28. I went ahead and broke down the 28 to 2 root 7. Again, not necessary, but knowing that that was 4 times 7, and 4 is 2 times 2. That's a pair of 2's with a leftover 7. Again, make that a solid 2 on the outside, leftover 7 underneath. Then finally, I went ahead and subtracted 8, which means the exact value answer would be negative 8 plus 2 root 7. And the other answer is negative 8 minus 2 root 7. Remember that those are two separate answers, but because 2 root 7 is irrational, I can't actually add them together without approximating. If I do want to approximate though, remember I can hop onto my calculator, and I already typed in here negative 8 plus 2 root 7 comes out to a negative 2.709. Notice the 5, so we're going to round that up. So negative 2.709. Or, and the nice part about our calculator is, remember you can always copy, so go up at top and copy that, and then when I go back I can just change that to a minus, so it'll be negative 8 minus 2 times root 7, giving you an answer of negative 13.292. Again, rounding correctly, we're going to round that up, so negative 13.292, and those would be your two accurate approximate answers. I hope that helps you solving quadratic equations with square roots. Remember that works really well when you have just a single x variable. Good luck and have fun.